In this lesson, we will explore safety stock and reorder point calculations, two essential tools for maintaining an optimal balance between inventory availability and cost efficiency. Understanding these concepts helps businesses prevent stockouts, manage uncertainties in demand and supply, and ensure a smooth flow of operations. Let's start with safety stock. Safety stock refers to the extra quantity of inventory kept as a buffer to protect against unexpected fluctuations in demand or delays in supply. It acts as a safety net that prevents stockouts when actual demand exceeds forecasts or when suppliers take longer to deliver. Without safety stock, a company risks losing sales, disrupting production, or disappointing customers. However, holding too much safety stock can lead to high carrying costs. The key is to find the right level that balances protection and efficiency. Calculating safety stock involves understanding two key variables: demand variability and lead time variability. Demand variability measures how much demand fluctuates from the average, while lead time variability measures how much the time to receive inventory changes from order to order. Safety stock equals Z times sigma DLT. Here, Z is the service level factor, representing the desired probability of not running out of stock, and sigma DLT is the standard deviation of demand during lead time. The higher the service level desired, the greater the value of Z, and thus the higher the safety stock. For example, a company aiming for a 95% service level will hold more safety stock than one targeting 85%. Now, let's discuss the reorder point, or OP. The reorder point is the inventory level at which a new order should be placed to replenish stock before it runs out. It ensures that inventory arrives just as existing stock is being used up, maintaining continuity of operations. Reorder point equals demand during lead time plus safety stock. Demand during lead time refers to the average quantity of items sold or used while waiting for replenishment. For example, if a company sells 100 units per week and its lead time is 3 weeks, the demand during lead time is 300 units. If the company also maintains 50 units as safety stock, the reorder point would be 350 units. When inventory levels reach 350, a new order is triggered. The relationship between safety stock and reorder point is crucial. While safety stock cushions against uncertainty, the reorder point ensures timely replenishment. Together, they prevent both stockouts and overstocking. These calculations are particularly useful in industries with fluctuating demand, long supply chains, or high service level requirements. Technology has made these calculations even more effective. Modern inventory management systems automatically track sales data, monitor lead times, and calculate reorder points dynamically. Some advanced systems use machine learning algorithms that adjust safety stock levels in real time based on changing market conditions or supplier performance. This automation helps businesses reduce manual errors and respond quickly to variability. It's also important to note that different products may require different safety stock and reorder point strategies. Fast-moving items with high demand variability may need higher safety stocks, while slow-moving or predictable items may require less. Similarly, products with long or unreliable lead times demand more conservative buffers. Categorizing inventory based on demand patterns and risk levels allows for more precise and cost-effective inventory management. In summary, safety stock and reorder point calculations are vital for ensuring inventory reliability and operational efficiency. Safety stock protects against the unexpected, while the reorder point signals when to replenish. Together, they provide a structured, data-driven approach to maintaining customer satisfaction while minimizing costs. By mastering these calculations and integrating them into automated systems, businesses can maintain the perfect balance between readiness and efficiency, ensuring a resilient and responsive supply chain.